So Jen, I had intended to just send you a PDF, but I can't help myself. I feel like I have to say a couple things about some of these questions. I'll try to keep my comments brief so the video isn't long, and you can fast forward if you don't need it. So find the terminal point on the unit circle. You had said you didn't take pre-cal, which I'm assuming means you've never seen a unit circle before. So this one we'll probably have to talk about in a Google Meet. But just to sort of introduce you to the concept. It's a circle. It has a radius of 1. And so the various points around the circle are just based on a 30-60-90 triangle or a 45-45 triangle. And again, we'll talk about that in more detail in a meeting if you would like. But this question says to find the terminal point on the unit circle determined by the angle 5 pi over 4 radians. You're probably wondering what a radian is. We can talk about that. But 5 pi over 4 is actually one of the known angle measurements on a unit circle. And so the way you want to think about this is if you started at 0 and you traveled around the circle until you got to 5 pi over 4, which would be right there, they say find the terminal point. So in other words, what are the coordinates that correspond to that point? And of course, you would have no way of knowing this without looking it up, but it's negative radical 2 over 2, and then negative radical 2 over 2. That is the answer to this question. And again, I don't want to go into a lengthy video on this. I think it'd be better if we just met and talked about it. Unless you somehow learned about this in one of your other math classes, but it's usually covered in pre-cal. So that's all I have to say about that. We can talk later. So Jen, this next question is dealing with composite functions. So they gave you two function rules, Q and R, and they asked you to find R of Q of -4 and then Q of R of -4. The better way to write this rather than using that circle notation in between the two variables is to use parentheses. So basically I rewrote them, and you can see that for the first problem, you're taking -4 and you're going to plug it into the G rule first. So you're going to start on the inside and work your way out. So you find G of -4. I got -7 there. Feel free to check my math. Then you take G of -4 is -7. So really now, if we replace G of -4 with -7, we're really now looking for R of -7. And that's what I'm showing just below my calculation of Q of -4. And so I plug -7, which was my output from the Q function, into R, and I get -49 there. And remember that negative sign outside in front of the x squared, you have to square the number first, which always comes out positive, and then you have to flip the sign. So that's how I got -49 there. And then for the next one, you're just going to do it in the reverse order. So the first thing you're going to do for the second part is you're going to find R of -4, and whatever that comes out to be, then you'll take that R of -4 output and plug it into your G function. So the output for R of -4, I got -16. So then I took that and plugged it into Q, and I got -31. So I hope that helped. So Jen, again, this next one is a trig question. So if you didn't have pre-cal, this probably will not be familiar to you. But we can talk about trig functions when we meet. Secant x is defined as 1 over cosine x. And you might have seen sine, cosine, and tangent in geometry, if you remember that. Tan x is sine x over cosine x. So I rewrote it as secant x over tan x is 1 over cosine divided by sine over cosine. And instead of dividing by that fraction on the bottom, I can invert and multiply. You learned how to do that in grade school, if you remember. Anytime you're dividing by a fraction, you can invert and multiply by its reciprocal. Well, when I flip it over and write it as a multiplication problem, I have a cosine top and bottom that I can cancel. So that leaves me with just 1 on the top and sine on the bottom. And 1 over sine x is defined as cosecant x. And again, that's a trig function that you're probably not familiar with. And so we can talk about that when we meet. So Jen, this one, they asked you to simplify, and you have a complex fraction. So a fraction within a fraction, actually two fractions within a fraction. But remember, dividing by a fraction is the same as multiplying by its reciprocal. So I just immediately rewrote it as a multiplication. And it's the bottom number, the denominator, that gets inverted when you rewrite it. So now what I have is 6 minus 3x on the top of the first fraction, and there's a GCF there of 3. So I pulled the 3 out, and that leaves me in parentheses with 2 minus x. And then on the bottom of the second fraction, I have 4 minus x squared. That is something, it's a binomial, two terms. There's no GCF there to factor out, but it is something called the difference of squares. I don't know if you remember that from your Algebra 2 days, but that factors into the square root of each term plus or minus. In other words, the square root of 4 is 2. So I'll factor it out again. The square root of 4 is 2. So in the first slot of my parentheses, I put a 2 and a 2. The square root of x squared is x. So I put an x and an x. And because this is a minus sign, the signs have to be opposite. I need a plus and a minus. And it doesn't matter which order you write that in. You'll notice when I work the problem down here, I put the 2 minus x before the 2 plus x. It makes no difference because you're multiplying. But the reason I did that was because they want you to simplify this. And that means that if there are any common factors, top and bottom, you want to cancel those out. So I now see, because I factored, that I have a 2 minus x top and bottom that I can cancel. And then also I have an x on the top and an x to the fifth on the bottom. Well, I can cancel out an x to the first. So the x on the top gets canceled and the x to the fifth drops down to an x to the fourth. Again, they don't have to be on the same fraction. Just one has to be on the top and one has to be on the bottom for it to simplify. So once I cancel out the common factors, top and bottom, I'm left with just a 3 on the top. And on the bottom, I'm left with an x to the fourth and a factor of 2 plus x. Now, you can leave it like that, I would assume, or you could multiply the x to the fourth through. I don't think it matters. I'm going to box in both of these. These are both perfectly legitimate forms of your answer. Jen, this is logarithmics from Algebra 2. There's a relationship between exponents and logarithms. You probably are going to need to talk to me about this, and I didn't want to go into a lengthy explanation because I'm trying to keep this short. But I will just, the final answer to this question is right there. So if that doesn't mean anything to you, I understand completely, because logarithms can be kind of tricky, but I can definitely clarify it for you and make the whole logarithm thing understandable. So we'll talk. So Jen, these answers might not make that too much sense to you if you're not familiar with logarithms. They were covered in Algebra 2, at least they were supposed to be. But logarithms have some properties that are analogous to addition, subtraction, and exponents. And the first property is that subtraction can be thought of as division when you condense it down to a single log. So the difference between two logs is the same as the log of the ratio, where the first number goes on the top and the second number goes on the bottom. And then for the second one, it's addition. The log of the sum, or the sum of two logs, can be condensed down to a single log if those two numbers multiply to give the answer. So in other words, I said to myself, 5 times what gives me 45? And the answer to that is 9. And then the last one, coefficients become exponents. So the log in base 3 of 16 is going to be equal to 4 times the log of whatever number, if I raised it to the 4th power, would give me 16. And 2 to the 4th is 16. We can talk about this more when we meet. So Jen, when I looked at this question, I just immediately thought I see it says the length of a triangle, but I'm wondering if you meant to write rectangle there, because it says the length of a triangle is 1 foot less than twice the width. I don't know. Usually if we talk about a triangle, we talk about the height and then the base, not the width. So I'm thinking, and then it says rectangle down here. So I think you meant to write rectangle, which is fine. I worked it as a rectangle. So they told you the length is 2w minus 2 times the width minus 1. That's how I got L equals 2w minus 1. And then they gave you the area was 21 feet. So I just said area is also the width times the length, and then I replaced L with 2W minus 1, so I'd have an equation that only had one variable. I replaced the area with 21, and then I have a quadratic because the W, the 2W squared, that's a quadratic term. That's how I knew I had to move the 21 over to the other side, set this equal to 0, and then factor. And we can talk about the factoring because it's a little bit trickier because you have a 2 in front of your W squared or your quadratic term, which we have not seen that before in the other factoring problems. But anyway, once I got that factored and set it equal to 0, I get two answers, but W equals -3, that doesn't make any sense because a dimension cannot be negative. So that's how I knew to opt for the 3.5. And then if I plug the 3.5 for W back into the L expression, which is 2 times W minus 1, I get L equals 6, and you can double check that. 6 times 3.5 is indeed 21. So I hope that makes sense. So this one, Jen, deals with rational exponents and also negative exponents, and they asked you to simplify it. So the first thing I did was I went to the bottom, and I have an x to the 1/4 times x to the -1/2. So when you multiply, you add the exponents. Well, I can't add those unless I have a common denominator. So I changed the -1/2 into -2/4. And then I added the 1/4 and the -2/4, and that gives me -1/4. Now, negative exponents, when they're on the bottom, can become positive if you move them to the top. If they're on the top and they're negative, you have to move them to the bottom to get rid of the negative sign. And you always want to get rid of your negatives. So I moved that x to the 1/4 to the top. That lets me drop the negative sign because I moved it to the top. Now I'm multiplying, so I want to add those exponents, but I need a common denominator. So I chose 12 and rewrote them as 4/12 and 3/12. And now I can add those and get 7/12, and that's my final answer. So Jen, this problem, again, they asked you to simplify. So the first thing you do is you multiply the numbers together. So I did 9 times 2 times 3, which gives me 54. Then you have to add the exponents for each of the variables separately. So for y, I have an 8, a 3, and a -5, which gives me a total of 6. And then for w, I have a 1. I know they didn't put an exponent there, but it's a 1. And then a -4, which gives me a -3. And then the v only had a 4, so that gives me a 4 for the v. And so now when I go to clean this up, I'm going to have 54 for my coefficient, or my number. And then I'm going to have y to the 6th. I'm going to have w at the moment to the -3. I'll have to fix that. And then I'm going to have v to the 4th. Now I'm not allowed to have that negative exponent, so I have to rewrite this one more time. The 54, the y to the 6th, and the v will all stay on the top. And then that w has to go to the bottom so that I can drop the negative exponent. And now you have your final answer. 54, y to the 6th, v to the 4th, w to the 3rd. So Jen, I put this one back in because I realized I forgot to find the vertex for this problem. It's in the other video. The way you find the vertex is you take the opposite of b over 2a. And so if you look in pink, I wrote out the general formula. Standard form for a parabola is ax squared plus bx plus c. So in this case, a is 1, b is 4, c is -12. We actually don't need the c to do the vertex. But so the x value of the vertex, if it's the opposite of b over 2a, then the opposite of b is going to be -4, and then 2 times 1, because a is 1. So that means that I have -4 divided by 2, and that's just -2 for the x value of the vertex. So the x value is going to be -2. I still have to find the y value, but all I have to do is plug it back in now to the equation, because I know that y is equal to x squared, so I'm going to take -2 and square it, and then I add to that 4 times -2, and then I subtract 12. So if I square -2, I get 4, and then I'm going to subtract 8, and then I also have a -12. So let's see, 4 minus 8 is -4, and -4 take away 12 more would be -16. So the vertex in this case is -2, -16, and you could graph that to check.